This is a demonstration of how to perform a Wirth's 4-light test. The Wirth's 4-light test is a binocular diagnostic tool useful in investigating retinal correspondence, which is the relationship between the area stimulated in the strabismic eye when fixing with the other eye, used to detect presence of binocular single vision, suppression, or diplopia, double vision. It can also be used for determining the dominant eye. Because it is dissociative in nature, it is not used to establish abnormal retinal correspondence. The test requires the use of red-green dissociative goggles and a specifically designed illuminated apparatus, which contains 4 lights in a diamond configuration, consisting of a red light and 2 green lights and a non-filtered white light, arranged as so. In this video, you will see the test being performed at distance. The patient will be situated 6 meters from the light source. This test can also be repeated at near at a distance of 33 centimeters, using a specially designed torch with the same arrangement of lights. The room lights will need to be dimmed during testing. They are left on in this video for the purpose of visibility during filming.
Bruce? Come through.
Hello.
How are you doing?
Not bad.
My name's Jack, I'm the orthoptist. Just going to perform a test just to see how well your eyes are working together. Just get you to put these goggles on for me with the red goggle for your right eye.
Conventionally, the goggles are placed with the red filter in front of the patient's right eye and the green in front of the left. Consequently, the red filter will only allow red light to enter the right eye, and the green filter will only allow admission of green light into the left. This then allows the clinician to interpret the findings and easily relate it specifically to either eye. The patient's own distance refractive correction should also be worn.
Is that okay?
Are you comfortable?
Alright.
Alright, just turn the lights off. Do you see the circles down the end?
That
See
chart.
the chart on the chart, the bottom of the chart?
Oh, I see them, yeah, too.
How many lights do you see?
I see 4 lights.
Can you describe those circles for me? The colour, changing the circles?
There's 2 green ones on either side. There's one on the right, one right on the left. There's a red light on the top, and there's like a yellowish coloured one at the bottom.
Okay.
Yeah.
Okay.
The results are recorded by indicating the test used, a description of the light seen, and finally an indication of what this means. This patient is demonstrating a normal binocular single vision response, seeing only the 4 lights, with 1 red light, 2 green, and a bottom light that's a combination of the colours given by the filter of the goggles. When communication may be a barrier to obtaining accurate results, for instance, when testing children, it may be easier to get the patient to draw what they see. Now let's have a look at an individual who, when tested on the Wirth's 4 lights, gives an abnormal response. During testing, it is important that the patient keep their head straight and both eyes open, that the clinician assists the patient in putting the goggles on with the red filter on the right eye and the green on the left, that the lights in the room are dimmed.
Okay, I'll just get you to look down at the chart for me. You straighten your head up for me, please.
Yep.
That's it. Now, do you see the dots?
Yep.
On the chart, yeah. Tell me, how many dots do you see?
So there's 5 dots.
5 dots. Now, can you describe where they are?
so there's 2 red lights on the left-hand side and 3 green lights on the right.
Okay. Are they next to each other? Is one higher than the other or lower?
The red ones are slightly above.
Okay. Do you see all the lights at the same time? Or
Yeah.
are they flashing?
No, they're all there at once.
No. Okay.
This patient is experiencing double vision as they are seeing 5 coloured lights, 2 red from the right eye and 3 green from the left. The double vision she is experiencing is referred to as cross diplopia. This is given that the red lights being seen by the right eye are located on the left-hand side. This indicates she would have an exotropic deviation. If the red lights remained on the right, it would be considered to be uncrossed diplopia, which is caused by an esotropic deviation. She also has a deviation of height, as the red lights are seen above the green lights, which actually is indicative of the right eye being lower than the left, a left hypertropic deviation. This response is recorded as so. Another possible response to the Worth's 4 light test is seeing either only the 2 red lights or only the 3 green lights. This means that the patient is suppressing with the eye whose coloured lights are not seen. It is important for the clinician to ask the patient when they are seeing 5 lights and then to further prompt them around whether all the lights are present at the same time or whether they are switching on and off. This is because the patient may be suppressing each eye in turn or alternating between suppression and binocular vision. Some of the positives of the test include that it's great for children as it's easy to explain and for the child to provide information. It's easy to record and interpret the results. It's quick and simple to perform in the clinic. And it's a good starting point when investigating the nature of the diplopia, whether it's manifest or intermittent, whether it's crossed or uncrossed. Some of the negatives of the Worth's 4 light test include its subjective nature, that the patient must have fusion and stereopsis, that the lights need to be turned off or dimmed, that the test is highly dissociative given the dimmed lighting and that there's no common colour to fuse, and that the dark filters are less like natural conditions and therefore less relevant to what the patient sees in their normal daily environment. This brings an end to our video. We hope you've enjoyed it and found it informative. This has been a La Trobe Orthoptics Student 2014 production. Thanks for watching.